Hello everyone. Today we are going to discuss the solution of ordinary differential equation using modified Euler's method. Now for a given differential equation dy dx equals to fxy. Here you can see for dy dx fxy with initial condition yx0 y0, we have to find the approximate solution using modified Euler's method. Okay, now what is the modified Euler method? It is given by y r plus 1 n plus 1 equals to yn plus h by 2 f xn yn plus f xn plus 1 y n plus 1 r, where r, the value of r will be 0 1 2 3 etc. Okay, where the Euler's formula or the initial approximation will be y n plus 1 0 equals to yn plus h f xn yn, where n equals to 0 1 2. And what is h? This h and this h is the step size. I have already discussed this in my previous video regarding Euler's method. Okay, h is the step size, that is, it is the difference between x1 and x0, x1 and x2, x2 and x3 and so on. Okay, and for your information, sometimes this Euler's modified method is also called predictor corrector method. Okay, now why we require this modified Euler's method? In the Euler's method, the tangent is drawn at a point and slope is calculated for a given step size. Thus, this method works best with linear function, but for other cases, there remains a truncation error. To solve this problem, the modified Euler method is introduced. In this method, instead of a point, the arithmetic average of the slope over an interval xt and xt plus 1 is used. Okay, now let us discuss this with one example so that you can understand it in easier way. Now, using modified Euler's method, find y 0.2 given that dy dx equals to x plus 1, y0 equals to 1, where y0 equals to 1 correct to 4 decimal places. Okay, now coming to the solution, given dy dx, that is fxy equals to x plus y. Also x0 and y0, these values are given. This one is x0 and this one is y0. Okay, so x0 equals to 1, y0 equals to 1. And what value for y we have to find out? For y x1, this is x1 equals to 0.2. it is also given, but see, in the question h is not given, so we have to calculate the value of h. How can we calculate the value of the h? That is the step size. H equals to x1 minus x0 equals to 0.2 minus 0, 0.2 minus 0, so it is 0.2. okay, now according to the Euler's formula, the initial approximation is y 0 n plus 1 yn hf xn yn. Okay, now put n equals to 0 here, y0 1 equals to y0, n equals to 1. okay, h f x0 y0 x0 y0. So this value we know already, so put the values of these y0 x0 and h. So 1, h is 0.2, x0 is also 0 and y0 is 1, so we'll get the value of y10 equals to 1.2. okay, now coming to the modified Euler's formula. Okay. The first approximate, the modified Euler's formula is y n plus 1 r plus 1 yn h by 2 f xn yn plus f x n plus 1 yn plus 1 to the power r. Okay, so this is equation 1. Now first approximation, put r equals to 0 and n equals to 0. So in equation 1, okay, so what value we will get if we put r equals to 0 and n equals to 0? See, it will become 0 plus 1 and 0 plus 1. So y1 1 y1 1, right? Next y0 h by 2 f x0 y0. See, f x 0 plus 1, that is 0, y 0 plus 1, that is 0, that is x 0 plus 1, so x1, y 0 plus 1, so y1, and r is 0, so y1 0, right? So we are getting this equation. Now putting all the values, already we have these values y0, x0, h, and y1 0 we have got from this equation, from the initial approximation, that is 1.2. so putting all these values we'll get 1 plus 0.2 by 2 into 0 plus 1, 0.2 plus 1.2. okay, and the phi if x0 y0 equals to x0 y0, because as per the question it is, the function is dy dx or fxy equals to x plus 1. okay, so by this we are getting x0 plus y0 and x1 plus y1 0, right? And after calculation we'll get y1 1 equals to 1.24. okay, now coming to the second approximation, put r equals to 1 and n equals to 0 in equation 1. What is our equation 1? This one is our equation 1, right? So r equals to 1, n equals to 0. Putting these values in this equation, we'll get y12 equals to y0 plus h by 2 f x0 y0 plus f x1 y1 to the power 1. okay, so putting all the values here, 1 plus 0.2 by 2, 0 plus 1, 0.2 plus 1.24, and we will get y12 equals to 1.244. okay, now what is the third approximation? Third approximation, put r equals to 2, n equals to 0 in equation 1. Equation 1, this is the equation 1, right? So for the third approximation, if we put the value of r equals to 2 and n equals to 0, we will get y3 1 equals to y0 plus h by 2 f x0 y0 plus f x1 y1 2. And putting all these values, we will get y1 3 equals to 1.2444. See, we have got 4 decimal places here, but we have to get the same value for y1, where they will be same for up to 4 decimal places. okay, now we are getting for the fourth approximation, put r equals to 1, r equals to 3, n equals to 0 in equation 1. Equation 1 is this one. okay, y1 4 equals to y0 plus h by 2 f x0 y0 f x1 y3 1. And putting all these values, this value y1 3 we have got from here, so we are getting y1 4 equals to 1.2444. now see, for value y1 3 and y1 4, they are producing the same value correct to 4 decimal places, 1.244. okay, so since y3 and y1 3 and y1 4 are same correct to 4 decimal places, okay, this y1 y1 3, yeah, they are same correct to 4 decimal places, so y 0.2 equals to 1.244. Okay, and this is the answer. Hope you have understood this problem, and also you have understood the modified Euler's method. Okay, if you have any question or any doubt, please comment in the comment section, and do subscribe for getting next video. Thank you.